Hey everyone, we've been talking about RIP, and we've saw that RIP is pretty straightforward, not very granular, doesn't give us a lot of enhanced capabilities, and have some pretty flaky default operations. And it being the way it is, the assumption here is that it should be recognize the fact that since it either multicasts or broadcasts these messages out, all enabled interfaces, we may want to be able to implement some type of security solution to help protect our environment. Now, when it comes to security, we have a number of features that we need to entertain, but right now in this particular part of our presentation, what I want to start focusing on is authentication. Now, authentication, again, is how I can ensure that two neighbors, and I don't even want to use neighbors, two adjacent, two devices that are talking on the same interface or more, have the capability of being able to isolate the identity of their partner, whoever they're communicating with. So it allows me, through authentication, to be able to prove beyond a shadow or a reason of a doubt that I am who I say I am. Now, in the world of Cisco, we're going to find that we have two main flavors of authentication. The first one is going to be text, clear text. So whatever passwords or whatever keys we have negotiated, we're actually going to be exchanging those keys across our links, and that's going to allow us to prove who is who. But the problem is that text implies clear text. So clear text means that there's no security applied to those passwords. So anyone with a sniffer has the capability of coming through and seeing what these authentication passwords are. Now, when we look at that, we're going to find out that using clear text is considered by people in the industry to be possibly more dangerous than not having authentication in the first place. Because again, a lot of organizations use the same passwords. So if you expose yourself this way, you could, in all actuality, leverage or allow someone to leverage the rest of your network by using clear text. Something that I recommend you never do in a production environment. The other scenario is MD5. Message Digest 5. Now, this is not to imply that these are the only two authentication key methods that we have, but in the context of RIP, it is the only two. So as we go on, as we progress, and we'll start talking about EIGRP and OSPF, we're going to find that we have other methods, and we also have other restrictions. Because not all protocols are going to support clear text because it is, as I said, so problematic in a live environment. Now, what we're going to do is this is going to give me the capability of utilizing another tool that we haven't talked about yet, and that's going to be called a key chain. Now, a key chain allows me to have multiple keys that can either be simultaneously or staged in activity. So in other words, I can rotate my keys. We're also going to take a look at some of the behavior of RIP, because there may be some situations or circumstances whereby we can have problems based on this key architecture and the fact that RIP is just so old and it's just been patched and modified over the years to allow us to be able to support these features like authentication. Now, looking at this, what I'm going to do is I'm going to pick two interfaces to play with. The first interface I'm going to play with is the interface that's going to be running between R2 and R3. And what we're going to do is we're going to configure this using clear text. So allow me just one moment here. What I'll do is I'll say we'll use clear text here. And then down here we will use MD5, Message Digest 5. So in other words, I'm going to be doing the configuration on these individual interfaces. So when we look at this, let's dive into the equipment and see what happens. We're looking at R2 to R3. So first of all, I want to create that idea of a key chain. And that's going to be through the key dash chain or space chain command. And I'm going to give it a name. I want to call it RIP _ AUTH for authorization. I'm going to specify a key. I'm going to say key 1. And I'm going to give it the code that we want to use. So the key string is going to be IPExpert, where the P is capitalized. Now looking at this, do show key chain, I can see now that I have the text that I'm using for my key. It is key 1. It's on the key chain of RIP authentication. And notice it says my accept lifetime is always valid and my send lifetime is always valid. Now what we're going to realize here, and I'm not going to walk through this part of the configuration, this is definitely something you can entertain on your own, but the main thing here is that we can actually stage this. I can say, well, send it from this time forward, stop it at this point, and then after a certain point, what I want to do is maybe send or use key 2. So again, this gives me the benefit of being able to have multiple keys configured in one key chain so I can rotate my passwords on a regular or a prescribed basis. Now what we also might want to do is make certain that we have an overlap with regard to that time so that we do not have, because of our clocks not being synchronized, a period in time where the systems can't agree on this idea of authentication. Now when we look at authentication in the confines of the devices themselves, what we want to do is we want to understand exactly what's happening, because when we go in and we start doing our config, how do I apply this key chain? Well, I apply the key chain specifically by going to my interface. So do show CDP neighbor is going to tell me who I'm connected to, and I'm looking at R3, so I'm going to use Fast Ethernet 02 locally to communicate to R3 on Cat2. So here's what we'll do. Let's go ahead and fire this up. So it'll be interface E02, and what I'm going to do is I'm going to say IPRIP Authentication. Now I said we were going to use clear text, so what I'm going to say is I'm going to say mode TEXT. Then I'm going to say IPRIP Authentication keychain, and the keychain that I'm going to specify is RIP_auth. Now what I'm going to find here is show IP route RIP. Let's take a look at what we're learning from 02. So right now our timer's at 27 seconds. Let's see if that timer keeps going up. Well, notice that timer's going up. It's now exceeded 30 seconds. Now, worrying about missing an individual packet in RIP might not be that big of a deal. So if this thing goes over 60 seconds, what we are going to have is we're going to have the absolute issue that we have missed an update and that we are no longer communicating to our neighbors. So let's take a look and see what's going on here. All right, we've just exceeded a minute of everything that we're learning from 02. Now, what I want to do is I'm going to go over to R3 and I'm going to redo my debug. So I'm going to say debug IP, and what I'm going to do is I'm going to say IP debug IP RIP. And let's see what happens here. Because what we're going to find is the system should give us some information associated with what it is we're trying to work with and learn. Okay, let's see. We're ignoring a packet sourced from one of our addresses. So that's not what I wanted to see. Ah, look here. Ignored a V2 packet coming from R2. The reason is it says it's invalid authentication. Okay, so that debug was helpful. It showed me the fact that the message that's coming from my neighbor is using some kind of authentication. But notice it doesn't tell me anything about that authentication other than the fact that it's invalid. Let's take a look at how we might be able to start addressing this. So first of all, I'm going to say uall config t interface e. Let's see here, just make sure I got my 03 or 02, excuse me. IP RIP authentication mode clear or text, excuse me. Do debug IP RIP. Let's see what happens now. All we did was just change our mode. Let's see if we get a different message. Because it said now that our authentication was an invalid. So let's see what ends up happening now. Will it change its message type that we're receiving? So we received a V2 from 2.1. That's not the interface that we're looking at. We're looking at E20. Okay, this one's dropped because it's coming from us. So anytime now we should start receiving one from E20. Notice it still comes up here and says invalid authentication. Now, let's look at what we got here. Well, first, the thing that we need to realize is the fact that I don't have a key here. So let's uall this, do uall. And let's create a key. We said keychain RIP_auth. We said key 1 was going to be key string IP with a capital P expert exit And now what we'll do is let's go over to R2 and see if we have any of those prefixes in our routing table still. Notice now it's telling me the link is possibly down. So in other words, the hold down timer is almost, or the flush timer is almost ready to cook everything out. So the hold down timer has expired. Go back over to 3. Interface E, do show CDP neighbors. Let's just double check this, make sure I'm on the right interface. Interface E02, do show run interface E02, and that's what I did wrong. Let's see here. I hate it when I make mistakes like this. Let's see, where did I do it? Do show run pipe include. Put it under the wrong interface is what I did. Probably 1, 2, knowing me. Let's try this again. IP RIP authentication mode text do show run interface E02. And see, notice it's not appearing in my command. So let's take a look and see what's going on here. So Ethernet 02 IP RIP authentication mode, well, we did that. Let's say keychain, and we will say RIP underscore auth. Do show run interface E02. Now notice it's there now. So let's see what's going on now. So IP RIP authentication mode text. Anybody see what's happening here? Notice it said IP RIP authentication keychain RIP underscore auth, but notice it doesn't say anything about clear text. Let's do that show all again. Let's do show run all, excuse me, all pipe, and I want to begin at interface FAO2. Notice right here, IP RIP authentication mode text. It appears there. So let's take a look and see what happens the moment I come up and look at another device. Let's say R1. Show IP interface brief. E assigned. Now we know we're running show run interface. We know that we're running RIP on all of these interfaces. So show run, notice it's not there, show run all pipe begin, and let's begin with interface Ethernet 0, 0. IP RIP authentication mode text. So the text mode is going to be the default config. So if you don't configure it and you just set a key chain, what's going to end up happening is it's going to use the idea of plain text. Now, what I said I was going to do is I was going to go down to 45 and I was going to do the matching configuration. Let's just modify the configuration that we have. All right. So what we'll do is on cat2, I'm going to go to the interface and I'm going to say IP RIP authentication mode MD5. We cut over here to R4 or R3. IP RIP authentication mode MD5 do show run interface E02. Now notice mode MD5 is operational. Now when we come over here, show IP route RIP. Now notice I'm learning prefixes from my neighbor. Just as a final verification, let's just do a trace route to 172.16.5.5. and it should shoot through R3. And it is. All right, so it went from R2 to R3 to Cat2 to R5. So what we've illustrated here is the fact that we have this idea of our configs, but there's another element that I want to notice here, and that, or point out here, and that is going to be the fact that we can add keys. So let's look at this. So first of all, show IP protocol. If you haven't determined it now, show IP protocol is one of my favorite protocols or commands. Fast Ethernet 02, it's telling me I'm using the keychain of rip off. Now it doesn't tell me specifically what key I'm using, but it tells me that I'm using the key rip authentic underscore off. So what I'm going to do is I'm going to come over here and I'm going to say config T keychain rip underscore off key 2, and I'm going to say the key string is going to be Cisco in uppercase. Now exit. Now, at first blush, we would assume that we're going to be up and operational. So show IP route rip. And notice my timers are at 28 seconds. Our timers are now at 6 seconds. $15. Let's see if it recycles at 30 seconds again. 20. 24. 2. So this tells me that I'm using my keys, but I only have the one key configured on R2. So what does that say? That says that the key that I'm using is going to be the key that is going to be accepted. So the question is am I sending both keys or am I sending one key? Well, let's take a look at this. So let's see, debug. I just got to remember the command, excuse me, one moment here. Should be debug IP rip. Let's see, no. Debug authentication. All. Let's let this percolate for a minute. It may not show me what I want to be able to see. Just going to wait for 30 seconds and see what goes through, if anything. Like I said, I don't think it's going to show me anything. Show keychain. Now, the issue here is notice that this says the accept lifetime and the send lifetime are always valid. And we can see, let me go ahead and all this because that debug's not going to show me anything. And we can see here that our system has two keys, but they're both going to be accepted and valid forever, always. Now, the issue here is that begs a question. What would happen if I came over to R3 and made a change? Well, first of all, let's remove this key. Config T, keychain, rip underscore off. And I'm going to say no key 2. Do show keychain. Okay, now let's go over to R3 and let's make a modification here. First of all, what I'm going to do is I'm going to say no keychain. Rip underscore off. Now, do show keychain. Have none configured, which I wouldn't expect to since I deleted it. So now what I want to do is I want to create another keychain. I'm going to call it the same thing. Keychain. Rip underscore off. Now what I'm going to do is I'm going to create key 2. I'm going to say key 2 has a key string of, and what I'm going to specify here is the fact that it's going to be IPExpert. Show run interface E02. Do show run interface. Okay, configurations are all here. We have the same key password, we have the same key string, but we have different key numbers. So let's take a look at this. Show IP route. All right, well, let's see. I'm not seeing anything on 2. So that's 3. There's 2. 11 seconds. Here, let's do this. Pipe include via 10.1 23.2. 2 seconds. Let's take a look over at R2. Show IP route RIP. Look here. 2 minutes and 2 seconds. So everything we're learning from Ethernet 02, which is going to be R3, is aging out of our routing table. So let's do this. Let's just make our lives easier here. I'm going to execute a clear IP route star. Show IP route. Well, let's see here. We've got 2.0, serial 2.0. I need Ethernet 2.0. So I've got my directly connected prefixes. But what we're going to see here is I'm learning nothing from my neighbor, from the other device. I'm not learning anything from R3. So can I ping? Ping 10 or 172.16.3.3. Yeah. But how am I going? Traceroute 172.16.3.3. Well, I'm going all the way to R2, and then I'm shooting out to get where I want to go to R3. I'm not taking the direct link across the 2. Now, we had the same password. Let's just double check that. Show keychain. Should be IPExpert with a capital P. Show IPExpert or show keychain. IPExpert with a capital P. And notice my key is 2. So let's do here. Let's say show IP route. And what we're going to see here is that we're not learning anything except one prefix here. And that's 26 seconds. Let's see if that actually refreshes, which it should. .23.2. But bear in mind, I mean, how we're learning that, it's the 23.2, that's going to be the actual link between these devices. So all I wanted to do is I want to illustrate the fact that the keys matter. The key numbers need to match. So let's go ahead and fix that problem on R3. What we'll do is we will say config T, keychain, RIP underscore auth, key 1, keystring, IPExpert, exit, 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 show, or debug IP routing. And let's wait and see if anything happens. Go ahead and debug IP RIP2. Got a lot of debugs running. I may have to increase the size of the screen. Again, like I said, it's slow, but we're going to change how to manipulate timers. Okay, now notice we're learning prefixes. Fast Ethernet, Ethernet 02. So now we're actually adding prefixes. So now exit. That wasn't what I wanted to do, en, UOL. Go back over to R2, do a trace route to 172.16.5.5, and we should shoot across to R3 via the VLAN 23 segment between R2 and R3, which we do. So we can see now everything's up and operational. We have everything configured. We're only running authentication on that one link, but that shouldn't be that big of a deal. The main thing that we want to pay attention to right now is the fact that our environment is actually up and operational. And if we wanted to, or if we so chose, we could do authentication everywhere. It just depends on what the exam specifies. Now, one thing I want to warn you of is that in a live environment, using authentication may be best practice. In the context of the CCIE version 5 routing and switching exam, only enable a feature if you're instructed specifically to do so. All right? So the main goal here is to just understand the fact that we have the capability of doing authentication via clear text or message digest. Clear text is going to be the mode if we do not configure it by default, verifiable by the show run all command, and also the fact that the keys actually matter in the modern iOSs. All right, with that being said, I'll see you guys in the next video series, again dealing with routing information protocol. See you there. Bye-bye.